Welcome back to DeepVisus, where vision meets depth. Today, we're diving into an incredibly thought-provoking paper that challenges our conventional understanding of intelligence. This episode, titled Beyond Automated Optimization, the Cybernetic Nature of Intelligence, draws its insights from the recently published article Cybernetic Materials for a Theory of Intelligent Systems by Anubhav Monga. Have you ever wondered if the artificial intelligence we hear so much about truly mirrors human intelligence? Or if there's something fundamentally different about how living beings think and adapt? That's the core question we'll explore today. We're going to unpack why many researchers, including the author of this paper, believe that our current AI models, often focused on automated optimization, fall short of capturing the full spectrum of intelligence as it manifests in natural systems. Let's start by clarifying some foundational terms that are crucial to this discussion. When we talk about cybernetics, we're referring to the study of self-regulating systems, how they process information, communicate, and control themselves. Think of it like a steersman guiding a ship. They constantly adjust their course based on feedback from the environment. This idea of continuous adjustment through feedback loops is central to cybernetics. The paper also introduces us to second-order cybernetics, which takes this a step further by emphasizing the self-referential nature of these systems. It's about systems that can observe and influence themselves, where the laws of their operation seem to write themselves. The paper argues that traditional Turing computation, which is the basis for most of our current computers and AI, operates within predefined rules and a fixed phase space. Imagine a chessboard with a finite number of moves. While incredibly powerful for many tasks, this kind of computation is fundamentally deductive, meaning it can only derive what is already implicitly contained within its initial programming. But what about creativity, adaptation to completely novel situations, or the ability to understand meaning beyond raw data? The author suggests that these aspects of intelligence require a broader concept of natural computation. This encompasses processes where the phase space isn't fixed but is constantly evolving, leading to emergent properties that can't be predicted beforehand. This is where living systems, which the paper refers to as vital systems, come in. These systems aren't just processing information. They're actively resolving it, creating new information in the process, and adapting in ways that maintain their own existence. A key distinction the paper makes is between these vital systems and truly intelligent systems. Intelligent systems are characterized by their capacity for anticipation, not just reacting to what's happening now, but predicting and preparing for future scenarios, even hypothetical ones. This anticipatory ability is deeply linked to what the author calls ontological expansion. Think of ontology as a system's understanding of what exists and how it works. When an intelligent system encounters a truly novel problem, one that doesn't fit its existing mental models, it doesn't just fail. It restructures its entire edifice of knowing, its internal network of models, to accommodate this new reality. This is what the author, drawing on Denison's work, calls Denison's razor. The capacity to achieve this ontological expansion through internal restructuring is the true hallmark of intelligence, distinguishing it from mere automated optimization. Artificial intelligence, in this view, typically operates within a predefined ontology, unable to truly expand its understanding in this dynamic, creative way. This leads us to the concept of impredicative or closed-loop complexity. This might sound complicated, but it's about systems where self-referential relationships, often seen as logical paradoxes in formal systems, are actually fundamental to their operation. The paper uses the term holonic complexity, where a holon is something that is simultaneously a part and a whole. Imagine a cell. It's a whole system, but it's also a part of a larger organism. These complex interdependencies and circular causality, where causes and effects feed back into each other, are vital for understanding living and intelligent systems. The paper further introduces ludics, a fascinating idea from Negarestani. This isn't about board games, but about a theoretical framework where meaning and rules emerge dynamically through interaction, much like a dialogue. In this game, systems constantly adjust their understanding and strategies based on their interactions with the environment and other systems. This contrasts sharply with fixed, pre-programmed rules and illustrates how intelligent systems can generate new meaning. Finally, the concept of instructional information is introduced. Unlike the typical idea of information as just data, instructional information refers to the functional constraints and boundary conditions within a system that actually shape its processes. For example, the way a protein folds into its complex 3D shape, despite being computationally intractable for a Turing machine, is a physical process guided by these inherent constraints. This is a form of material implication, where the physical process itself is the proof. So, to return to our initial question, does artificial intelligence truly mirror human intelligence? Or is there something fundamentally different about how living beings think and adapt? Based on this paper, the answer is a resounding not yet. Current AI excels at automated optimization within predefined parameters. However, true intelligence, as seen in living systems, involves a dynamic, self-organizing process of ontological expansion, where systems can actively restructure their understanding of reality, anticipate novel situations, and engage in circular causality through interactive logic loops. This goes far beyond simply processing information deductively. It's about creating new information, new meaning, and new ways of being in the world. Thank you for joining us on this deep dive into the nature of intelligence. We've only scratched the surface of these profound ideas, and there's so much more to explore. In our upcoming episodes, we'll continue to unravel the fascinating world of the brain, the mind, and the very essence of intelligence. Stay tuned to DeepVisus, where vision meets depth,